All right, this is a week 4 video. This is video number 10, and this is just the basics of truth tables. So I'm not going to be talking about how to apply them yet. I'm just going to show what it means to make a truth table for a sentence. And actually, before we even do that, we want to return to the idea of a main connective for a sentence in SL, because one of the tricky things that people always say they don't understand is understanding what order you're supposed to do things in when you do truth tables. So to understand what order you're supposed to do things in, we need to go back to the definition of a sentence in SL. The sentence is defined recursively. That means there was a base class and then rules for expanding that class, right? So we said that there's a base class. Officially, there's a base class, a set of rules for extending the base class, and then a closure rule that says only things in the extended base class fall under the recursive definition. So in this case, our base class is just the individual sentence letters, A, B, C, D, and then you start putting them together like Legos using the sentential connectives. So the extension rules all say that if something is a sentence, then you can put a connective in front of it or attach it to another sentence with a connective and get another sentence. So you can imagine that we just start out with a pile of sentence letters. An extension rule says we can take the A and put a negation in front of it, and it's still a sentence. There's another sentence rule that says we can take the D and the E and connect them with a conditional, and it's still a sentence. So you notice now that we go from our base level to our level 1 sentences. The level 1 sentences have one connective in them. We can also connect up 2 level 1 sentences using extension rule 5. We connect them up with an OR. This is then, we can think of it as a level 2 sentence. So let's take a look at this. The OR here is the main connective. It is the main connective because it is the last it is the last connective that we added when we were building up the sentence in layers like that. The not and the conditional are secondary connectives because they were in the sentences that we put together to make the they were in the sentences that we put together to make the final sentence with the main connective. So we define the main connective as the last connective added when building a sentence recursively. So actually the first set of homework, the first set of questions in your homework is just about identifying the main connective of a sentence. So in the example problem, you have this A implies C and not D sentence. In this case, the main connective is the ampersand there. And you can tell that because the conditional is in parentheses. That means it's lower down in the table where you built up the sentence. The negation is also lower down because it's just modifying the D. Another way you can think about it is that the AND unites everything in that sentence. The AND unites A implies C, and it unites not D. Whereas the not in not D just modifies the D. And because of the parentheses, the conditional in A implies C just talks about A and C. All right. So once you start, once you recognize that every sentence has this structure where the connectives were actually put on in layers, you can use your basic truth tables to create more complicated truth tables. So at the bottom here on the left, you see the truth table for the negation, right? It just tells you that if A is true, not A is false, and vice versa. And then on the other side, you see that A and B, if you have a true A and a true B, then the sentence A and B is true. And that goes down for the rest of that table. So now we want to know about the sentence at the top of the slide, not parentheses A and B, right? Where the negation modifies the full sentence. So the negation there is the main connective, and the and is the secondary connective. So if we want to make this into a truth table, we can do the same thing we did before. We establish our four possibilities. So A and B, if A can be true or false and B can be true or false, then that gives us four possible combinations of truth values, right? And since these are the same as they are in the characteristic truth table for the and, we can just say that this column here goes there, right? That is, we know that if A is true and B is true, then the sentence A and B is true. So we represent that by putting the T under the and. Notice that we're not putting it under the main connective because we're not doing the full sentence. Right now we are just representing the truth value for one part of the sentence, A and B. All right. Ultimately, though, what we want is to know the truth value for the full sentence. So now imagine that script A isn't a single letter. Imagine that script A is this sentence A and B, right? So script A now represents a separate the column that we've already done, that is true, false, false, false. We want to negate that. So we just imagine, we start here. On the top line, that's true. So we put that into the table over there. We say script A is true. If that's the case, then not script A is false. So we put that false there. And that goes on for the rest of that table. So under the negation, you see false, true, true, true. This column represents the main connective, and therefore that is the truth, those are the possible truth values for the whole sentence. Okay, I just want to take a second to show you now how to write these up since we're doing these online. So ordinarily when you are doing the homework in person, it's easy enough to write truth tables with a pencil and paper. When you're doing them on a computer, there turns out to be all sorts of different ways to do it, and some are fancier and more time-consuming than others. So if you look at the Word document version of the homework, what you can see here is you've got this sentence as your question, right? And then to do a full truth table for it, well, one thing you can do is actually use the table function in Microsoft Word or another word processor. However, that is complicated, and so I'm not asking you to do that. Let's try a different example here. So you've got this problem, not parentheses S if and only if P implies S. The easiest way to actually do this, do a truth table for this, is just to type the characters all right next to each other. So we say not S, right? If and only if P implies S. And in fact, since I was using special characters there, and you may not have that option because you don't have the macros that I do or whatever, you could actually do it like this, right? Right. So that would be the sentence there. And then to do the truth table, you just do it on another line. This is going to be tricky, though, because you want to do these things in a particular order. For starters, you want to start by doing the columns under the individual sentence letters. So we're going to start with S, and S can be true, whoops, or false. Let's try and get these to line up. 1, 2, 3, 4. Sorry. So we've got true, true, false. 1, 2, 3, 4. False, like that. And then P, true, false, true, false. And then S again is going to be true, true, false, false. So you just line it up like that using spaces. Now the next sentence here is P implies S. So the main connective for this sentence is the negation. The secondary connective is the biconditional, and then the connective that is lowest down is the conditional. But notice that although we've got what looks like the regular characteristic truth table for a conditional, the order of the sentences has been reversed. So here on the left-hand column, it goes true, false, true, false. And the right-hand column goes true, true, false, false. Normally for the truth table for the conditional, that's the other way round. So that just means that things are going to look a little different in the center column. So remember, with the truth table for the conditional, if both sides are true, the whole thing is true. We also learned that if the left side is false, the whole thing is true. And that doesn't really correspond to anything in ordinary English. That's just an arbitrary rule that we have set up for our system. So the only time the conditional is false is when the left side is true and the right side is false. So that's what we put there. Then with the biconditional, we know that the biconditional is true when the two sides match. So here we've got a true because you're matching this true with this true. And then we also have a true here because you're matching this true with this true. And for the third line, the two lines match because you're matching this false with this false. So that's true. But for the fourth line, they don't match because you've got a false here and a true here. So that is false. And then finally, that gets flipped around by the main connective. The main connective with this negation is going to be flipping the values of what is under this biconditional. So this biconditional goes true, 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 false. We're going to flip that over here, and it's going to be false, oops, false, false, true. So this isn't as neat and clean as it might look for other things, but I can easily read it just because I know the order of the things. For this row, if you're saying false, true, 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 and that's correct. And you can see that here when you look at the answer sheet, right? The column under the main connective is false, 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 true. And it's here marked in red, and it's spread out more evenly, but it's basically the same thing. If you want to submit your problems in Carnap, things are a little bit cleaner looking, but you have to fuss around with all these drop-down menus. So here's the same problem in Carnap. Carnap has put off on the left side your basic truth values for P and S, and actually they have arranged this so that P gets true, true, false, false, and S gets true, false, true, false. So you want, when you're starting this out, you want to make all your S's match and all your P's match. So S is going to be true, false, true, false. P is going to be true, true, false, false. And then this S is going to be the same way. So it will be true, false, true, false. So now this time around, the P implies S has the truth values arranged exactly the same way they are in the regular truth table. So you get true, false, true, true. And again, the biconditional works when the two sides match. So here you're matching this column, and my cursor is being difficult. The column under the S and the column under the conditional, they match here, so it's true. They match here, so it's true. They match here, so it's true, but they don't match at the bottom, so it's false. And again, the negation just flips that. Notice, by the way, that Carnap uses a different symbol for the negation. It uses what they call the turnstile instead of the tilde, the little squiggly line, but it just means the same thing, and so it's pretty easy to make sense of. In any case, we hit check, and we get success. Okay, so that's how to do basic truth tables in Carnap and basic truth tables in general. For the next video, I'll talk about how to apply those truth tables so that you can use them to determine things like whether an argument is valid or whether a statement is a tautology. And again, we'll be looking at how to submit those problems either on Carnap or just in a word processing file.